Hi everybody and welcome back. So today we're going to be talking about a few things, but I want to start off where we left off last time. So if you remember, last time we actually left off by creating a wonderful triangle. And that was pretty cool, but you know what would be even cooler is if we could take it a step further and create something like a square. So how would we do that? Well, in graphics programming, pretty much everything is actually represented by triangles. So if we wanted to create a square, we would have to do that by drawing two triangles on the screen. Now, this wouldn't be too difficult, but we do need to be a little bit careful about how we do that. Let me kind of show you what I'm talking about by drawing this out for you. So we can start out by drawing just one triangle, and that's fine, and then we draw another triangle laid on top of it. Here's kind of where the issue comes in though. So these triangles are connected, and they're connected at these two blue points here. But if we just drew the two triangles, then those two same points would take up double the memory. And that's an issue. This is where index buffers come in. Essentially, index buffers allow us to store the information of one index and use it multiple times without having to have another blob of memory pointing to that same location. This is going to be great in terms of optimization, and while it might not seem like a big deal when we're just drawing one square and it just is sharing these 2 points, whenever you have a lot of stuff that you're drawing on the screen, this can actually be a really big deal. So let's kind of talk about that, and I'll walk you through how we create something like that. If I just run this here for you, then you can see that we get this lovely triangle. So how did we get here? Okay, so let me kind of walk you through what's happening here. So we have 4 points now. If you remember from last time, these positions there were actually 3 of them because we just had the one triangle that we were representing. But now we have 4 of them because this is the 3 points on the original triangle plus the one unique point for the additional triangle that we're adding on top of it. That way we can create our square. And 2 of these are going to be shared. And then underneath this, you'll see that we have these indices. So this is actually representing the triangles that we're creating. This is really what the index buffer is. So you can see this is 0, 1, 2. So this is saying that for our first triangle, use index 0, index 1, and then index 2. And then for our second triangle, use index 2, index 3, and then index 0. And this will create our 4 points, and this will create our 2 triangles so that we have our square. And this is really mostly what we have to pay attention to when we're talking about this kind of small scale representation of our index buffers. So now that we've gotten kind of the basic information about index buffers down, I want to talk about something called uniforms. So what is a uniform? Well, a uniform is a way to get information, get data from our C++ file into our shader. That way we could write something changing the shader in our C++ file and have that actually affect the shader. And a really good example of this would be our current color of our square. So right now our square is really just one solid color, and we want to change that. Let's say that we want to define that within our C++ file, or let's say that we wanted to change that color over time. And obviously this can be extracted into a lot of other things as well, but this is just a really good example of what we're currently doing and how we can use it in that way. So I'm going to kind of show you how we would do that, and it should be pretty chill. Let's get right to it. Okay, so here is our basic.shader file, and you can see here that I've defined this uniform vec4 color variable. So this is representing our uniform color variable that we'll be able to access and change from our C++ file. So it's a vec4 because this is the RGBA, so this is 4 numbers that are going to be represented there. Now back to our C++ file, and you can see here that we have accessed our shader, which is something that we had already done before, but now this is something else that we have. So we have location equals this get uniform location shader, and then uColor, and this is the same variable that we defined. And this is the same variable that we defined here. This is our uColor for uniform color, and you have to make sure that you spell this correctly, otherwise it won't work. And this is just making sure that that is not nothing. And then let's keep going on. And yeah, like I said before, we kind of want to create something where we are changing the color over time. So this is R, which is the literal R in RGBA, and then this is the increment of how much we want to change it, so by 0.5, let's say. So, and remember from last time that this RGBA in OpenGL is actually represented between 0 and 1 instead of from 0 to 255, but it's really essentially the same. Onward, you can see right here, there's a GL uniform for your location. This is that easy, guys. It's that easy to change the value of our shader. This location is the location that we defined up here of uColor, and we are just giving it this vec4, which is the RGBA value. And continuing down here, let's say that we wanted to change this over time. Let's say that we want to change this over time. All right, so then here you can see we have this if statement checking, okay, is it more than 1? Because obviously if it's over 1, then it is more than the 255, and that would not be okay. So then we kind of lower that increment, and then we see, okay, now else if this R is less than 0, you know, we don't want that either. So we'll add a little bit more there, and it'll just continually pretty much switch the color back and forth every time. And let me go ahead and run this for you so you can see what is going on. And here it is, guys. It switches back and forth between this greenish color and this red color. Pretty cool, I know. So this is very generally how uniforms work, and then I kind of showed you how I used that in a small case of changing the color from the C++ file, and also not only just changing it from the C++ file, but changing it back and forth as it goes on throughout time. But what else have I done? So this is still kind of in the process, but something else that we're trying to do is I'm just trying to kind of clean this up a little bit. So if you remember, especially from last video, I showed you pretty much everything was in the same one file except for the shader. But I want to extract this even further. I want to abstract these different items into different classes. So I'm just going to kind of walk you through that kind of process, what I've done so far, and we can walk through that together. All right, guys, we are back in the code, and you can see here on the right, which you may or may not have already noticed, that we have more files over here. So mainly what I've done is I've created files for our renderer, our vertex array, our vertex buffer, and our index buffer. I'm not actually using all of these right now. I'm not using the vertex array right now. I've only just started doing that, but we can talk about a little bit more about that next time. But right now, I will talk to you about the renderer, the vertex buffer, and the index buffer. So let's kind of start. Let's start simple. Let's start with the renderer header file and C++ file. So this is really for asserts and for this GL call, which is used for error handling. And you can see this is the header, and then over here, we have created our C++ file that just defines these things from our renderer.h. And yeah, it's that simple. We just took it straight from our application.cpp. Nothing too crazy. Okay, guys, so here we have our vertex buffer header file. So if you don't know what vertex buffers are, then you can check out my last video where I did talk about that. But just continuing onward, so we have, I'm just defining this so that we have this vertex buffer class that we can reuse throughout the application.c++ file, so that we don't have to just redefine it every time that we're using this. So you can see we have these different things, and then we go ahead and define those within the C++ file for the vertex buffer. And now let's continue on to the index buffer. And this is pretty similar actually to the vertex buffer, but now we also have this get count here. This is our index buffer C++ file. Nothing too crazy. I think this is pretty self-explanatory. Just defining the items that we defined within our header file. Okay, now let's head back to our application C++. So we did include both of the, or all three of these, the renderer, the vertex buffer, and the index buffer. So, and we just went ahead and we replaced everywhere where we had, where we used vertex buffers and index buffers before, and now we are using the classes that we created. Here is where we have our vertex buffer and our index buffer, and you can kind of ignore the stuff that's commented out here. This is just me preparing for using the vertex arrays, but we don't have that just yet. So here's our vertex buffer, our index buffer, and this is really like very similar to what we had before, except now we've just kind of condensed it down into our vertex buffer and index buffer classes, and we're using them as such, and it just makes it a lot easier. And yeah, we have our bind and unbind, nothing too crazy. There you have it. So this was a pretty casual, laid back video. We just kind of walked through some stuff that we've done. I know that this might not seem like we've done a whole lot since last time, but you know, we are moving along, and it's been a pretty crazy last couple of weeks. So I think that once stuff starts to calm down a little bit, then we should be able to get a lot more done and just continue onward with OpenGL and even continuing on to our fluid simulation stuff. So that should be pretty exciting. Thank you so much for watching, and I'll see you next time. Bye.